In this video lesson, we are going to learn how to find the inverse of a 2 by 2 matrix. So I would like you to pause the video and take your notes. If we review the notes, it says if the determinant of a matrix A, and here let's define our matrix as A, B, C, D. If that determinant is 0, then A is a singular matrix and it has no inverse. But if that determinant of the matrix is not 0, then the inverse of A exists. And you can calculate the inverse of matrix A using this formula right here. So first off, just a reminder, the determinant of a matrix is calculated, of a 2 by 2 matrix, is calculated by taking A times D and subtracting B times C. And also, a reminder, we use the -1 superscript to denote the inverse of matrix A. So the inverse of matrix A equals 1 divided by the determinant of matrix A, and this is a scalar that you're going to multiply this matrix by. And I want you to pay careful attention to the order of the elements in this matrix. The order of the elements, take a look at this diagonal. In our original matrix, we had A and D. What we've done here in this matrix is we've switched their positions. And then what we've done with B and C, we kept them in the same location, but we changed their sign. Okay, so if we calculate the determinant again is AD minus BC. This is a scalar that we multiply by this matrix right here. All right, so let's go ahead and determine whether matrix B and C is a singular matrix or if it really does have a determinant. An inverse matrix. So let's calculate its determinant. The determinant of matrix B equals A times D, which is -3 times 3, minus 6 times -1, and that equals -9 plus 6, which equals -3. So since this is not 0, matrix B has an inverse. It is not a singular matrix. So let's go ahead and calculate the inverse of matrix B. Well, let's go ahead and do this first step right here. We'll create our scalar, which is 1 over the determinant. The determinant was -3, so we'll put that here. And then we need to build this matrix here. Remember, we're switching along the forward diagonal. We'll switch these two elements. So this matrix becomes 3 and -3 this way. And all we're doing is changing the sign of these elements. So this is going to be a +1 and this is going to be a -6. +1 and -6. Now all we have to do is multiply by the scalar we created and we have our inverse matrix. So 3 times -1/3, -6 times -1/3, we have 1 times -1/3, and we have -3 times -1/3, and when we simplify, the inverse of matrix B is -1, +2, -1/3, and a +1. Let's go ahead and do another example. Let's see if if the inverse of matrix C exists or if matrix C is a singular matrix. So we will go ahead and calculate its determinant. The determinant of matrix C is 2 times -10. We multiply along this diagonal and we're going to subtract the product of this diagonal, 5 times -4. And what does that equal? -20 minus -20, which is going to give us a 0. So the inverse of matrix C does not exist. So we would go no further after we figured out that it does not exist. So now what I'd like you to do is write this matrix down and determine whether it is a singular matrix or if it has an inverse. If it has an inverse, I want you to go ahead and calculate the inverse like we did in this example right up here.